Oh, hi. So I just wanted to talk a bit about, well, the homework assignment and I'm going to extend the homework assignment, give extra credit to those who turn it on time and give a few extra days to those who need maybe just started late. Okay, so I've just been getting some questions about it over the weekend. Okay, so let me just talk about a couple of things here. Okay, there's a few like comparators that we have to write, three of them, I think. Okay, so like the price comparator. So it actually has two criteria to compare book objects. And so one is, okay, first we're going to compare, let me see if I can make this a little bit bigger. So like book one is greater than book two, if the price of book one is greater than book two. But let's say the prices are equal, right? So of course, if book one's less than book two, if the prices of book one is less than book two, let's say the prices are equal, then we use the number of pages, right? Number of pages in book one, same price, but book one is more pages, then it's the larger book. And vice versa, if book two has more pages, that's the larger book. Okay, so we actually had a similar problem in homework three. Yeah, the student class implemented comparable, and we compared by last name in ascending order, which is really common, like in a phone book or something. That's what you would do if you looked up a name. Of course, no one uses a phone book anymore, but if we did, or some kind of list of names on on paper, um, they have maybe they have online phone books. I don't know. Anyway, but let's say if a list of names, lots of names, you'd compare. You want to look up the name. You would look up the last name. That would be your criteria. It'd be your initial criteria is the last name. But if the last names are identical, then you look at the first names, and then you start comparing by first names. And this was our code, right? First so the last name. This is for the student class. We're comparing by last names in ascending order. So just use the built-in compare to method that every string has. Last name is a string object. It has a compare to method. And if the last names are equal, then compare the first names. So that's the code for that's from homework three, but it's kind of similar here. So just compare the prices. If the prices are the same, then take the difference in the prices. If that's zero, then take the difference in the number of pages, and that's what you return. Okay, so then there's two other comparators, a title and an author comparator, and we're using dictionary ordering. So like the title is a string, the title of a book is a string, the author name is a string, and we're gonna use the position of the title name or the author name in the dictionary. The length doesn't. Some of you are comparing by length. That's irrelevant. It's dictionary positioning. It's alphabetical ordering, either ascending or descending. So just once again, just use the built-in compare to method in the string class. Like here's an example where in this case, this dot last name compared to O dot last name. Well, this would be in ascending order, right? So okay. Okay, so now there's this method. Oh, I thought I had uploaded, shoot. I thought I had uploaded um, I thought I had fixed this. I guess I did not. I know, I'm going to upload a correction, but there really should be, okay, so here's the first parameter. There's actually a second parameter, remember? And it's comparator E. Right? So we want to find the largest element in an array list. It's just like finding the largest like integer in an array of integers. And we have to have a way of comparing, so we're going to use the comparator to compare. So we're storing an array list of E objects. Now E may not implement comparable. You're not guaranteed to have a compare to method. So that's what the comparator is for. Okay, so we're going to we want the largest value. So just assume that ARR get zero has the largest, and then you loop through the array list object, like with the for loop, to determine if there are values greater than largest. And the logic is exactly the same as finding the largest integer in an array. Okay, so then now here's another method. There's a greater than method. It has three parameters. We're passing in an array list filled with values, E values. There's a comparator that allows us to compare values. And then there's some value, then there's a value. and we're going to create a new array list. What we're going to do is that all the values in ARR that are greater than value are going to be put in this new array list. So it's similar to the greater than method in homework 4. Okay, so just declare an array E object called temp, and then just loop through ARR and add data in ARR that's, so add data in ARR that's greater than value. And again, how do we know if a value in ARR is greater than value? You have to use if you're not using that comparator, then you're definitely doing something wrong, right? We're passing it in as a parameter. We either should be using it or it shouldn't be a parameter. Okay, so yeah, so just declare an array list object called temp, and that's what you're going to return. Loop through the array ARR, and not the array, loop through the array list ARR, and anything in ARR that's greater than value you add to temp. Okay, so that's for the most part. I'm not actually done yet. Now we have some review material. So we do have a couple of methods in the homework 5 where you want to know if every value in an array list has a certain property, or if one value in the array list has a certain property. We did it at the beginning of the year, and so a lot of you are writing questions, and maybe you're not realizing that it's really very similar to what we've done before. So let's do some review problems. This will be the basis of your very last quiz, which will be on Wednesday. Okay, so you're gonna have these. So here's an example. We have these 5 methods. Okay, and so are all the methods in all the values in S. So this first one. Are all values in S is the length greater than 6? Now, now this one, is there at least one string in S whose length is greater than the length of value? All hundreds placed equals 7. So we want to know if every integer, so this is an array list of integers. We want to know if every integer in there has the number in the hundreds place equal to 7. Like this would, well, that's equal to 7, and yeah, see the number in the, we want to know if every number in the hundreds place is equal to 7. Somehow you have to be able to extract the number in the hundreds place. And then here we want to know is at least one value in the array list an odd number and greater than 40. So if you remember, and now we're going to do these. I guess since I'm not here, I guess it means I'm going to do them. Okay, so let's see here. Okay, all lengths greater than, okay, so remember for these alls, we want to know if every element of a set has a given property. So we assume that it's true until we find a contradiction. Okay, so for the alls, just assume that every value has that property, and as we loop through the array, what if we find one that doesn't? Then we know it's false, because what we're saying, every value has to, like in that first one, we have every string has to have a length greater than 6. We look at the first one, oh, the length is greater than 6, and then we look at the next one, oh, the length is greater than 6. Oh, the third, oh, the length the length is only 3. Just stop. You've already know that it's false, because at least one value defies the property. Okay, so like now the ones where there's at least, where all you have to do is find one value that satisfies the property, assume false, assume no value satisfies the given property. And as you loop through the array list, if you find one that does, stop. You know, once you know it, so for the alls, once you know it's false, stop. And for the at least, once you know it's true, just stop. Okay, and so let's see here. Okay, so let's I actually have this set up on Eclipse. So let me just open Eclipse, and oh, that was my hearing my cat kind of doing something. It's a little weird, you know, working at home and there's noises in the house. Okay, all hundreds place equals 7. So this is an all, right? So so here the first, so we have an all at least, like the first one, every element of AR has to satisfy the property. The second one, just one value. The third one, they all do. And the last one, just at least one property. Let's just set up the Boolean values right now. So here it's Boolean flag is true, because it's a for all. What's our other for all? It's this one right here. And the other ones are at least, all we need is at least one. So Boolean flag, we'll just initialize it to false. And then The last one is also just, all we need is one value to make, for the whole thing to be true. There's at least one value satisfy the property, but we'll assume by starting no value satisfies the given property. Okay, so, and then of course we're going to return flag. And now the methods will actually compile, though they don't really do anything interesting right now. Okay, so every single one of those methods compiles. It's returning a Boolean value, but it's not doing exactly what we want to do. The first one returns true every time. The second one false. The third one true, and the last one false. Okay, so all hundreds place equals 7. So we have to get to the number in the 100. Oh, that's the array list. Okay, let's start with these string ones. Okay, all lengths greater than 6. Okay, so let's do the first one with a while loop, and then maybe we'll do. Let's do the first two with while loops, and the second two with for loops, just to have, just so we won't get bored. So while loops, we actually have to initialize the counter outside the while loop. And then so while, so the name of the array list is S. Well, S dot size, index is less than S dot size. We don't have a length property, we have a size method. Because it's an array list. So with an array, it would be length and flag, right? And students, notice the first time, before we even iterate, flag is true. So we're going, while index is less than size and true. So we're not worried about, so if size is greater than 0, there's no problem about this iterating. Because sometimes I see students, it's almost like, I don't know, sometimes it's like you're guessing. I guess that's not, to be blunt, about what the initializing flag, and is it not flag or is it flag? But just substitute the first value of flag, and sometimes I see it where you're not going to get any iterations, and I'll show you a different example. Okay, so all lengths greater than 6. So here's one way to do it. So let's say if what's the name of it? So s dot get index. Let's say it's less than 6, less than or equal to 6. Here's one way of doing it. Flag equals false. So if we find a string whose length is less than 6, or less than or equal to 6, let's say let's say we have cat, the length is 3, right? The length is 3. Oh, s dot index dot, that's, I actually have a compiler error, don't I? That's better. We need to measure the length. So we use the length method. So every value of s is so s dot get returns a string. S dot get index is a string. We take its length and we see if it's less than or equal to 6. So if it's cat, you're going to get 3, and then the flag is false, because we only want it to be true if every string has a length greater than 6. Okay, so then the next time, so let's say the first string is cat. So flag would be get set to false, and then you check the Boolean expression, and false will give you, even if index is less than size, and false is going to be false, because the and is the expressions on either side of the and have to be true for the whole thing to be true. And then we better increase the incrementer, which I'm famous for not doing. Otherwise, you're going to get an infinite loop. Okay, so let's look at the next one here. Okay, so so the very last one here. So hello. Just scroll down now. Okay, so line 30, public static Boolean contains length greater than value length. Okay, so we're going to do the same. So we're going to start index. We'll use a while loop. Int index is 0. And so while index is, and the array list is called s dot length, no, s dot size, sorry. Now let's say we did and, I see some of you doing this sometimes, and flag. Well, what's going to happen the very first time before you ever iterate? Okay, let's say the size is 20. So 0 less than 20 is true and false. you're not gonna, you'll never iterate, and so this is guaranteed to always return false. So if you put, so if flag is initialized to false, and you go and flag, you'll never iterate through the while loop, and then you'll just go to the return state and you return false. So the correct expression is not flag, right? I'm sorry, we not flag. We can't type it. Let me try this one more time. You come back in 10 minutes and maybe I'll have this typed properly. Okay, there we go. And we want to set, and what is that, what value of flag on line 33, what value of flag makes that loop stop? True, not true is false. When flag becomes true, the loop will stop. And so we want to know, so we'll just do this way. Flag is assigned, a little different than the previous method. Flag is assigned s.get index. And we want to know all the lengths greater than okay, so dot length is it greater than the length of the value? So value is an input parameter and it's a string. And if that's true, flag is set to true. So example, let's say the value is door. So like house and door. So this would be, flag is true. So get index is so let's say for some index we store the string house there and the value is door. Yeah, that's when the flag would be true because the length of house is greater than door. So flag, my cat doesn't normally do this. Then flag is sets to true. So then it gets set to true, and then the next time you evaluate the Boolean expression and not true, you get false and the loop stops. Also notice for this flag, you don't actually have to write an if statement, but it's not that that's the worst thing in the world. And then you return flag. So if the value of if every string is a length less than the length of value, flag will stay false and you return false. So okay, so should we do the other two? Okay, so I think I heard someone say yes. All hundreds place equals 7. So this is a for all, so flag is set to true, and now I'm going to use a for loop. And you're probably, how can you use a for loop and make the loop stop? Okay, so int index is 0. Okay, so the index is less than, the array list is called arr.size. Oh, now this is something I would never do in math 130. Okay, so I'm actually have a compound Boolean expression in the for, like in the Boolean, the Boolean expression for the for loop is a compound Boolean expression. Okay, so flag is false, the for loop stops. And I normally would never write a loop. Now I'm more liberal about this, but I think when I first started, like years ago, I would never write a for loop like this. I would say for loops, you should know for loop is only when you know the exact number of iterations. But I guess I'm not as more easygoing now. So as I've really grown, I guess, as a programmer. Okay, so anyway, so students. Okay, so now let's see let's do flag is equal to okay, so flag is set to true. So we want this to stop. So okay, so we want the loop to stop. If flag is false, we want the loop to immediately stop. And if the flag is true, we wanted to do one more iteration. So I'm going to go. So how do we get the number in the hundreds place, right? Like, how do you get the number in the hundreds place? So let's say you have like 5, 6, 3, 9, 8. The number in the hundreds place is 3, right? 3 is in the hundreds place. So what do? You go 5. So 5, divide that by 100. 5, 6, 3, 9, 8, divided by 100, you get 5, 6, 3. And then to get the number in the tens place, now to get that number that used to be in the hundreds place, you mod it with 10. Okay, so we're going to take the number, we're going to go arr.get index, and I'm going to divide it by 100. So I get a number that basically we just lop off the rightmost two, the two most insignificant digits, and then we take the remainder with respect to 1. And what I'm saying is this equals to 7. I'm not saying you would have to write it this way. Notice how there's no parentheses, right? There's no parentheses. And some of you might want to put parentheses. Maybe it makes it easier to read. I think more parentheses are harder to read. So here, like another way, I guess if I wanted to put in parentheses, I'd go, maybe I would go, students, why do let's go back to line 9. That assignment operator, the one that's directly to the right of the flag, that's the lowest order of precedence. That's always the last thing that gets evaluated. So I know that everything on the right side of that, what looks like an equal symbol, is going to be evaluated first. We're going to do that comparison. So one way you could do this is, well, AR, you can put parentheses around there. I think it looks better not to have the parentheses, but if you're really confused at first, and then you can go, okay, so now we're taking that number and dividing it by 100, and then modding it, now getting the number in the hundreds place. I don't know, whatever combinations of parentheses you think would make it easier for you. You can put them in, and I always highly discourage it. My feeling is only put parentheses in when you have to. It makes the code more readable, and it makes it look like, sometimes when we put too many, sometimes parentheses are put in when they, it gives me the impression that the programmer thinks they have to be there. Maybe they don't understand they don't have to be there. So I think it makes a better impression not to put the parentheses in. Okay, so I'm digressing here. So anyway, we're done. We're done with this method. Right, so let's look at again. So flag, so this is a for all, flag is set to true. And then here's and the Boolean expression looks just like the Boolean expression for a while loop. We checked if the index is less than the size and flag. So the very first time, flag is true, right? So the flag isn't what, so before you ever, if flag was false and we had and flag, it would never iterate. Or if flag is true and we had not flag, we would never iterate. But so this is fine. And then we just check the number in the ones place. So again, so if the number is 5, 6, 9, 3, 8, right? You divide by 100. Okay, so operators at the same level of precedence are evaluated from left to right. So the division and the modulus are at the same level. So first we evaluate, we take 5, 3, like here we would take 5, 3. If that was the number that was in the array list, we would take 5, 6, 3, 9, 8, divide by 100. That gets rid of the 9, 8. And then we take the modulus 10, and that would give us the 3. So that was the number originally in the hundreds place, and just compare it to 7. All right. Okay, so now let's, the very last one. I'm kind of sad, students. Okay, so at least one is odd and greater than 40. So let's just use, because we did 2 while loops. Now let's do 2 for loops here. So I'm just going to cut and paste, which you're not really supposed to do. So I went to a long lecture about this in my last class. Sure, stop it already. It can, the thing we don't like about cutting, like I cut and paste all the time, even though I'm not supposed to. I don't think doing this on a job, if you do this on a job and it causes you to, introduce bugs into a program, your employer is not, whoever is paying you is going to be very unhappy with you. The reason with cutting and pasting, we think it's going to help us, it's going to make life go faster. And often what we do is, okay, we can cut and paste, it looks just like what we had before, except we need this little change. Sometimes we forget to put the little change in. And so we have some code in there that really shouldn't be there, and it just causes grief. So this shortcut that we take by cutting and pasting sometimes can just add hours to the programming time. Okay, but here I know, so in this case, like here, flag is false, right? So I know I better change that flag to not flag. And if I don't, then it's never going to iterate, because and false is false. So there's the kind of thing that I'm cutting and pasting and I forget to put the not sign in front of the flag. Okay, so now all we have to do is check to see does ARR.get give us a number that's odd? Mod 2 equal 1. And is it also has to be greater than 40? ARR.get index greater than 40. And if both, so let's look at line 19, that's giving me a compiler error. Why? Oh, too many ands. Okay, so So first we have to see, so remember you take the mods with respect to 2, and if you get 1, the number's odd. And we wanted to know, if we wanted to know if if the value is greater than 40. If both those expressions are true, flag is true. If just one is false, at least one, and greater than 40, yeah. So if at least one of them is false, then flag is false. And again, this loop will stop. The loop in line 18 stops when flag becomes true. Not true is false. So let's say we take this array element. Let's say it's like so let's say the array element is, I don't know, 809. Well, you take the mods with respect to 2, you get 1, right? Okay, so get index mod 2 equals 1 is true, and ar.get index is greater than 40. The flag would become true, and then you increment, the increment occurs, the index would increase by 1, and then you go, was index less than ar size? Okay, so and if that's true, but then you would compare, and not flag, and if flag is true, not flag is false, the whole loop stops and you return true. Okay, so flag is always false, but let's say all our numbers are like let's say all our numbers are like or like 4 and 10, maybe some numbers greater than, like an odd number greater than, less than 40. Let's say they're all like that. Flag will always be false. The loop will never stop. I mean, the loop will stop until you get till index is equal to size, and then you return false. Okay, so I'll have some methods like this on the quiz, and I'm going to put this file up for us to look at, for you to study. So this will be our very last quiz. And hopefully, and you do have, why did I talk about this? You have methods like this on homework 5. Right? There's methods like this on homework 5. So so it's like all greater than initialize flag to true, and at least one greater than initialize flag to false. But you need a loop where you look at every single value. Okay, so much for that. And now, now the real exciting part of today's lecture, the code for the ArrayList class. The code for the ArrayList class right here. Okay, so this is not, you're not tested on, this is knowledge for knowledge sake. I used to give assignments on this, so I guess the one thing, this won't take me too long, if this is more in case if you're interested in algorithms or something, this might help you, if you go to a 4-year school in computer science. So in ArrayList, we teach it in Math 130 or the first course in Java programming, and it makes it look like it's like an infinite array. You just if you want to add an element to an ArrayList, you just use the add method, and it looks like you can add, it's like this infinite array. It's like magic, but it isn't. See, the ArrayList is really one of the instance variables for an ArrayList. Well, there's 2. There's size, that tells you the number of elements you've added to the ArrayList. And then there's actually this instance variable called list, and it's an array of type E, and that's where all the data. So every time you add, let's say it's an ArrayList of strings, you add cat would be assigned to that array. Now the problem is that ArrayList, the list, that array on line 6 eventually will get filled up, and you have to kind of fake increasing it. Okay, so let's look at the constructor. So we're going to initialize the list to a length of 10. Now, E is actually a generic type. It represents a class name. Now, only the compiler knows about the generic variable E. Once we actually compile our code and convert it to bytecode, anything to do with generics is taken out. So the runtime environment doesn't know anything about generics. And so the one thing is that we cannot create an array of a generic type. So let me just show you. If I go E, I want to assign memory to E. So if I go list is assigned new, let's say like E, like 9, an array of 9 elements. So look there, I get if you look there to the left of 10, I get a red dot. Cannot create a generic array of E. You cannot create a generic array of, you can't create an array of a generic type. So let's say, okay, but you can actually declare an array of generic type. Now, how do we assign it memory? Okay, the thing is, all generics, and it's more detailed than I've talked about in this course. I do talk about it, when I'm teaching in class, actually in person. All generics actually get converted. Anytime you see generic like E, it actually gets converted to object. It gets compiled and gets converted to object. Okay, so here on line 10, remember object is the top level class of all. It's the only class that doesn't have a parent. So we declare an array of objects of type of length 10, and I'm going to cast it to an array of type E. That's the trick we have to do. Basically, we're telling the compiler, yes, I know I have a generic array. Please do this anyway. Because at runtime, that array of type E is just going to become remember, all the generic variables are going to convert it to objects. So that array of type E, that array list, is really going to become an array of type objects. But what happens is that we're only going to, let's say E is string, we're only going to be allowed to add strings to it. So, so the add method, the compiler will make sure, what the compiler does is when you add, it only will allow us to add whatever, is of type E. So let's say if we had an array list of strings and we tried to add, let's say like a book or a person object to it, we would actually get a compiler error. So, okay, so yeah, I'm sorry my phone's so loud. Normally I'd have my phone off, but I guess at home I don't. Okay, so anyway, okay, so now I got distracted here. Okay, so the array list. So anyway, so here's something that's not so obvious, line 10. Okay, so we're assigning memory to that instance variable list, but you have to do it in this kind of unusual way. And it's not obvious, and the only way you know to do it is someone tells you. Right, so if I want to assign memory to a generic array, you have to declare an array, you have to allocate memory for an object array and then cast it. Okay, so now let's look at a couple of methods, the famous add method. Okay, so initially we can have 10 elements in this array list. The number, but the size is 0. That doesn't mean we have 10 elements in the array. It's like a movie theater with 10 seats or a classroom with 10 seats. Initially, they're all empty. Before anyone walks in, they're all empty, but we can seat up to 10 people. Okay, so that's what that's what that list variable is like. We can actually add up to, we can add 10 elements to our array list, but initially the array list is empty. Size tells you the number of elements in your array list. Okay, so every time we call the add method, we're adding at position size. So initially size is 0. So the first time we add an element to list, first time we assign a value to the list array, we're assigning something to list of 0, because initially size is 0. Okay, but we want to make sure what happens if, okay, but let's say we've added 10 elements, 10 values to this array list. Let's say an array list of type string, we've assigned 10 strings. So positions 0 through 9 of list are filled. Then what do? We have to double the size of the array. We kind of fake increasing the size of the array. And so let's look at this add method. If size is greater, because so everything is in position 0 through size minus 1. So if size is greater than list.length, we call this ensure capacity method. So this means that the list array is filled up. All the seats are taken, right? We have 10 seats in our movie theater all taken. Let's get some more seats. So we call the ensure capacity method. And what we do, we pull the same trick. We actually declare an array that's twice the length of list. And again, we allocate memory for an object array, cast it to an E array, and we'll call this array temp, and we do system array copy. We're copying from list starting from position 0 into temp. So let's say the first time list is an array of length 10, that means temp would be an array of length 20. So we're copying from list to temp. The first 10 elements of list are copied into temp. So the first 10 elements in temp are identical to the list, and then there's 10 more elements that are empty. And then what we do is assign the address to list to temp. So that list variable is assigned actually a new address, right? So remember initially list would refer to an array of length 10. If we call ensure capacity, it's going to be referred to an array of length 20. It's a totally new array. It just that we've copied all the old values to this new array, and that old array gets just removed. It's not being used, so the Java garbage collector just frees it up, and it all goes away. Okay, so after we call, let's go to line 25. We're now guaranteed that there's room in the list array for this element that we're adding. We're adding at the end of the array, and we're actually always adding at list of size. We always add it at the end of the array list. And very important, increase size by 1. They're on line 27. And this add method always, when you're adding to the end of the array, at the end of the array list, you always return true. So that might seem strange. The thing is that in Java, we have all these collection classes, linked list, array list, there's one called set that doesn't allow for duplicates. So that, and we want the same methods, just for some consistency. We define the same methods in all of them, like add and remove and, and contains. And so like for this, like for a set object, the add method might return false. So if we're trying to add something that's already in there, the add method would return false. So, but in the array list, the add method always returns true. So we're going to skip, we're going to talk about remove index. We're going to talk about two more methods. So let's look at this remove int index. So we're going to remove from position index. So what we have to do is shift. We're going to use the array list. We're going to use the system array copy. So we're going to remove position index. So here, like that example 103, let's say our array list has cat, door, house, zebra, day, and we remove 2. Well, house is at position 2. So what we do is we take zebra and day and shift it 1 to the left, and then decrease size by 1. So zebra, instead of being at list of 3, would be go into list of 2, and day being at list of 4 would go into list of 3. So what we do, we use the array copy. Now the array copy, the source, and we haven't done this in a long time, but the source, remember it's source, initial index of source, target, initial index of target, and the number of elements we want copied. So the source and the target are the same. You can have that in array list. So we're gonna copy from starting at position index plus 1. That's 1 to the right of index. And we're going to copy into index. So we're going to take what's in index plus 1 and move it into index. Like here, we're going to take what's in position 3 and move it into position 2. So we're starting at position index plus, we're removing index. So we started at position index plus 1 and shift the whole thing to the left 1. And how many values, and how do I know? And the number of values copied is size minus index minus 1. So how many, students have a hard time with this. I know you do this in Math 265. How many elements are you copying? It's always last minus first plus 1. So the very last element, so we're taking the very last element in list that's considered part of the array list is size minus 1. And the first is index plus 1. So it's size, look there, so line 106. Size minus 1, that's the last one. Index plus 1 is the first one, and you add 1. And you get size minus index minus 1. That's the number of elements that are copied. Like here, my example, index plus, so size, the size is 5. So size minus 1 is 4. And index plus 1 is 3. So 4 minus 3 plus 1, we're copying 2 values over. That's not so important now. Okay, so anyway, and then of course decrease the size by 1, and then we actually save the element that was stored in the value that we're eliminating. The important thing I would just want you to understand is not necessarily all the details. I just want you to understand that underneath an array list is really this array object, and it's just a lot of bookkeeping. Either we're expanding the array by actually declaring a new array and copying all the old values into the new values. When we remove index, we remove from the middle, we're shifting all the values in the array over just by 1 with like a system array copy. So it's a lot of details. It's a lot of bookkeeping. And to me, at least a large amount of programming is like this. It's a lot of little details in which I was thinking of like computer science, at least this part of computer science. You have to like if you're the type of person like puzzles, like really detailed puzzles. Then this is kind of a good area for you. Okay, so now the very last thing, students, we want to see if we can use the for each loop, right? Because this is our very own MyArrayList class. So we have to implement, to use the for each loop, we have to implement iterable. Remember, iterable is an interface that has one method called iterator. So we have to, so our ArrayList has to have this iterator method. An iterator returns an uppercase iterator, which is itself an interface. So this iterator method on line 118 has to return an object whose underlying class implements iterator, E, where E is actually the generic variable. And so in the linked list, we defined an inner class, right? Because no other class needs this, class that returns this iterator object other than ArrayList. So we're defining a class inside of a class. We're going to call it ArrayList iterator, and it's going to implement iterator E. So it means it has to have two methods, a has next and a next method. So if you remember the code for linked list, we declared a node called pointer and we initialize it to head, and that's going to advance to the linked list. Okay, so the equivalent here is defining an index, like an integer index. We'll assign it 0. That's the very first element of list. Okay, so how do you know you're at the end of the list? When index is size, we're done. Okay, so if index is not equal to size, has next is true. When index is equal to size, we're done, right? Because all the elements in the array list are in position 0 through size -1, right? No elements in the array list start at 0, just like an array. So if there's 10 elements in our array list, they're in position 0 through 9. So let's say we're moving through our array list, we start at 0, and then we go to 1, and then we go to 2. When we get to size, we've gone off, we're outside the array list. So when index is equal to size, has next is false. Okay, so we have that has next method, and then there's this next method, and it returns what's actually at position index. We say what's in position index, and that's what's going to be returned. And then we move to the next element in the array. Okay, so we're starting at position list of index. So where I said, so index tells us where we are in the list array. So we start at 0. Okay, so we're returning something of type E. So let's just say what's in list of index, and which we do on line 131, and then increase the index by 1, and then we return what was in list of index. So I kind of do in this I've hardly done in this course. I go temp is assigned list of index plus plus. So we're kind of combining to short it. That's that post increment operator. So that's equivalent to temp is assigned list of index in one statement, and then doing index plus plus. Okay, so, and that's all there is. So now let's just test this. So we add cat. So this is our very own array list. Okay, so we add cat, we add dog at the end. So it's cat, dog. So then in position 1, we add zebra. In position 2, we add house. So it should be like cat, zebra, house, dog. And then we're going to add the numbers 0 through 9. We just convert them to strings. So cat, zebra, house, dog, 0 through 9, and print it out. And then we're going to remove what's in position 6, which I think is a 2. So let's just try this. Hello. Okay, the tension is mounting here. Okay, okay. So yes, so we had cat, zebra, house, dog. Isn't that what I said? I think that's what I said. Yeah, cat. Yeah, we had cat, zebra's at 1, house is at 2, and then dog. So that's what then we printed out. And then we had the numbers 0 through 9, and then we printed out. We converted 0 through 9 to strings. And then I say, we're going to remove what's in position 6. They're on line 159. So what's in position 6? It was, well, dog is at position, because cat's at position 0. And then zebra's at 1, house is at 2, dog is at 3. So 2 is at 6. So we're going to remove the 2. And that's what happened. We did remove 6. Yeah, so on line 159, we did remove 6. That removed the 2. So then we just go ahead and print. And then we remove the 2, and then we decrease the size by 1. So these methods work. So again, this is I think this is useful to know if you go on. Certainly how about iterators, and also just maybe gives you a better understanding of the my ArrayList class, what goes on underneath it. So I've already presented some of the code. And I think, yeah, so definitely understanding, the code for ArrayList and linked list, I think it'd help you if you go into like 3rd and 4th year of computer science. I'm not saying it's the most important thing, but it might be useful. Okay, and I guess I'm going to say, are there any questions? So I'm going to end here. I'm going to stop the recording.